Nepal, high in the Himalayas, is one of the poorest countries in the world. The mountains that define this landscape are proving to be a natural barrier to development, preventing electricity from reaching many of the people who live here, and literally keeping them in the dark. But a Canadian scientist has found a high-tech solution that could light up every corner of this country and offer people all over the Third World a brighter future. For centuries, the Kingdom of Nepal, perched between India and Tibet, has been a crossroads of cultures and a place of pilgrimage for those wanting to pray at its holy sites. But away from the bustle of the capital, Kathmandu, the people of Nepal are facing a challenge: how to develop a country with few natural resources when 80% of the population lives in remote villages, often only accessible on foot. Living in the world's highest mountain range, many of Nepal's 24 million people have no access to electricity. Days are short, and once the sun sets, they must find other ways to light their homes.
The primary source of light, apart from just the fire in a typical rural Nepali home, is a kerosene wick lamp. It doesn't give very much light, it's very smoky, it's unhealthy, it's very dangerous in fact. Many of them are just simple bottles, and if they do get knocked over, they basically become a Molotov cocktail. The kerosene also has to be got to the village, which means the villager has to travel someplace to get it. And kerosene can take anything from 10 to 30% of the annual income of some of these poor rural villagers. The impact of not having enough light is immense. In many parts of Nepal, the children are working in the fields during the day. And this is the same in many other countries, which means if there is a study time, it's usually in the evening. And if there's no light in the home, there's no way they can study.
It was whilst trekking as a tourist in 1997 that Scots-Canadian Dr. Dave Irvin Halliday began thinking about how he could help people here get clean, affordable lighting. As an electrical engineer, he knew that the cost of extending mains electricity into the mountains would be prohibitive. But a solution might lie in lighting that could run off small amounts of electricity generated in each village. Dave thought Nepal could leapfrog traditional lighting, which is costly and wasteful in energy, and opt for an emerging technology, so advanced that it hadn't even been adopted properly in the West: solid-state lighting.
If you think of a village of 100 homes of that, and each home is supposed to have like a 50 or a 100-watt bulb, you're dealing in kilowatts. That's very expensive to generate. I just thought there had to be some way of using solid-state light-emitting diode type lighting, which only uses a few watts to provide a useful level of light. But also, they're very rugged and reliable, and they're very low on the development curve. There's an enormous amount of potential left in solid-state lighting. It's going to be the lighting of the third millennium, there's no question.
Traditional incandescent light bulbs have changed little in over 100 years. When electricity is passed through a bulb, 90% is wasted as heat rather than light. Light-emitting diodes produce virtually no heat, making them many times more efficient and far longer lasting. But until recently, LEDs could only produce small amounts of colored light, and so were only used as power indicators on everything from cassette players to computers. But once back in Canada, Dave heard about a Japanese company that had made a breakthrough and invented a new, powerful white LED that might be suitable for home lighting. So he sent off for some samples and began to experiment.
I'd have to say that probably one of the most meaningful experiences in my life was the day that we actually switched on our first white LED. We'd been in the lab for 5 minutes to let our eyes get dark. This was at 1/10 of 1 watt. And when we switched it on, I remember, like it were yesterday, saying to my technician, good God, a child could read with the light of a single diode.
Armed with the first generation of white LEDs, Dave designed a simple lamp that could run off a portable battery and used less than 1 watt of power. In 2000, he and his wife paid for lamps to be installed in 2 remote villages to prove that this new technology would work in the mountains. Dave also had to find an efficient way to charge the batteries that was environmentally friendly, easy to use, and cheap to make. The answer lay in a simple pedal generator.
Our projects were initially funded entirely by my wife and I. It's because, to be quite frank, money was tight. We came up with a situation that we could afford. We divide the village into equal parts, so there's 8 homes per generator. The villagers bring their batteries to the generator every morning and spend about half an hour recharging them. The real beauty of pedal generators are their utter simplicity and ruggedness, and the fact that they can be used by anyone of any age and any gender, 24 hours a day.
Able to charge up to 4 batteries at each sitting, the pedal generators were extremely effective. But far greater impact came from the clean, safe, smoke-free lighting that the villagers could enjoy for the first time.
I think the feeling I had when we first saw the lamp switched on was something akin to when my children were born. I think it was a very humbling moment. That's really, for somebody that speaks so much, I'm a kind of a wee bit short on words when it comes to describing the fact that a child actually maybe has light for the first time in its life. For me, it's almost indescribable. But you can see it in the people's faces that you've done something meaningful for them.
Encouraged by his success, Dave set up the Light Up the World project to spread his high-tech lamps throughout Nepal and beyond. But for a country where the average annual income is only $250, emerging technologies are expensive. At around $60 per household, Dave had to try and reduce the cost of the lamps to encourage the Nepalese to buy the systems for themselves.